Okay, good morning, everyone. I think you can hear me very well, right? With this very sensitive microphone. So my name is Paco de Cruz. I work for Deloitte in the platform engineering practice. I see some familiar faces over here. And the topic of this session is Azure Develop Functions. So how many of you have worked with Azure Functions? Quite a few? Yeah, okay. So this is an extension of functions, and so the agenda of this session is, first I'm going to give you a bit of an overview of what serverless is and what Azure Functions are. Also, then I'm going to go deeper into the Develop Functions topic. So what are the concepts, what are the challenges they are trying to solve, what are the patterns in different components. Then I'm going to do a brief comparison between Logic Apps and Develop Functions, which are both serverless offerings on Azure. And then I have two demos, so if we have enough time, then hopefully we finish two demos. This session I have covered in 40 minutes, but I also take like 70 minutes, so depending on the questions, feel free to ask me at any time. And yeah, depending on the time at the end, we will cover one or two demos. So this is more or less, this is of course not in scale, but this is more or less how the different compute options we have on the cloud. So we have on the y-axis, we have more control at the top or less control at the bottom, and then on the x-axis we have more productivity at the right and less productivity at the left. So if you want more control but you are less productive, you can use just VMs or what they call IaaS, infrastructure as a service. Then we also have offerings like container as a service, where you have abstracted the VM, but you still have to manage containers. And then we have PaaS, which is platform as a service, where you don't need to worry about VMs, you only deploy your applications. And then we have function as a service. And then we also have what they call low-code platforms. And on Azure, this would be the offerings that we have. So you can spin up VMs in Azure and then deploy whatever, but you would need to manage and patch your VMs. Then we also have Azure container instances, where you can deploy just Docker and then run them on demand. They call them serverless containers. You don't need to worry about servers. And then we have app service, where we can deploy web apps or API apps. And this is all managed, so you don't need to worry about VMs. And then we have Azure Functions, and then for low code we have Logic Apps. So the last two offerings would be what we call serverless, where we don't need to worry about VMs or anything, we just worry about our solutions. And Develop Functions is of course an extension on top of functions. So what are the benefits of serverless? So when you are developing serverless solutions, you don't need to worry about servers, you don't need to worry about scaling, for example. You just worry about your code, how your code is gonna work. You focus on the business value, and then scaling happens on event base. So when you're, for example, if you're deploying an app or a web app on an app service, you need to worry about, okay, for example, resource utilization. So you say, whenever the memory is reaching 80%, then I need to scale to a new unit or a new instance, or the memory is reaching 70%, I scale to a new instance. So you worry about resources. On serverless, you don't worry about resources, you only worry about events. And these events will spin up instances on demand for you. So you need to worry about this. This happens in the background. You need to understand how it works, but you need to worry much about it. And you only pay for what you use, so it's what they call micro-billing. So you only pay when your function is running. If it's idle, you don't pay for that time. So Azure Functions in a nutshell. So functions are code that you run in the cloud, and you have different triggers. So you can trigger a function, for example, when you put a file in a blob container, or when you receive a message in a service bus queue. So you have different triggers, different binaries, input binaries, that would input messages into the function. Then the function will have some code to execute, and then the outputs, again, you can put on a blob container, or a queue, or you can even send emails via SendGrid, or send text messages via Twilio. We will see SendGrid in our demo. Yeah, so we have different inputs, different events that could trigger this piece of code. Then this piece of code will execute, and then there will be outputs after this event. We can also, for example, share these functions to run every 5 minutes. So we have different triggers. Is this all clear? Yeah. Make sense? Okay, so when we're running these functions on the cloud, we have some limitations. So these functions that we are running, when we're running here, they are meant to be single purpose, right? So this what they call nanoservice. So these functions have to be very, very specific and single purpose. But if we want to start building distributed solutions or more complex solutions, we have some limitations. Some of these limitations would be, for example, if we have nanoservices that communicate to each other. So let's say we have function A, B, and C, and then function A executes and function B executes, but then function C fails. How do we manage this error handling? How do we compensate if function C fails? How do we roll back what function A actually did? If we put messages into a queue, then it would be very hard to say function C now need to care about what function A did, right? So we will be breaking the single responsibility principle if we did that. So this would be one of the challenges when we start implementing these nanoservices. Other challenge is, for example, if we want to do parallel processing, we can easily from one function, from the first function, we can put, for example, 3 messages into 3 different queues, right? And we would have 3 instances of 3 functions running in parallel. So finding out is very easy, but how do we find it? So how do we control that when these 3 functions in the middle have finished, then we have a 4th function that has to take care of the output of these 3. It becomes quite cumbersome. Another challenge is, so for example, if we have a long-running HTTP, HTTP API, so how do we, so let's say this HTTP API takes, I don't know, 10 minutes to execute. So we cannot be waiting for the response, right? Usually an HTTP client would time out after 2 minutes. So how do we call for a status? At the moment, with just functions, it's very hard to do that. And then what if we wanted to use, let's say, a repeating process that has a state? Is something that we cannot do at the moment, well, without extension. It's something we cannot do just with functions. Or what if we have, let's say, some human interaction? So let's say we need to receive an input from a person, and then based on that input, we continue with the process. It's kind of hard to do it just with the functions. And then the last challenge is what if we have different external events that we need to correlate in a function because we only receive one event and we can only react to one event. It would be very hard to correlate different events that are somehow dependent on each other or are related to the same process. So these are some challenges that we have if we are implementing functions. But then Euro functions provide some patterns that we can leverage to overcome these challenges. So in Euro functions we have an orchestrator, and this orchestrator allows us to create like a sequence of functions. So we can orchestrate, okay, execute function A, and then execute function B, and then if function B fails, we try 5 times with exponential backoff period, for example, between the executions. And then if function C fails, we can implement some compensation or rollback of what function A and B did. So we can do that with the other functions. We can also implement fanning out and fanning in very easily. We will see this in the demo. We can also implement a long-running HTTP API, and we can implement provide an endpoint where the client can be calling for the status. We can also implement a repeating process that is stateful. Every time it executes, store the state somewhere. We will see. We can also implement human interaction, so we can wait for human inputs and then continue with the process. We will see this in the demo, and we can also correlate external events. Yeah, so all of these challenges that we have in functions, we can implement with Euro functions. So Euro functions in a nutshell. So we have functions, but then we have an extension on top of this functions runtime, and then everything is abstracted using the durable task framework, and all the state is persisted in Azure storage. Everything is abstracted, so we don't need to see what's happening behind the scenes. We can see, but we don't need to see. We will see this in the code as well. We can implement stateful workflows based on this durable functions framework. So we have different components. So we have the client, and then we have the orchestrator, and then we have activity functions. So the orchestrator is the one doing all the magic. Here is where we can have all the state. So the orchestrator is the one managing the state. It's like a process manager. It's like a workflow, but this workflow is written in code. We can call activity functions. We can do this retry. We can do exception handling. We can implement fallback or compensation. We can do checkpointing. So, well, actually, it implements checkpointing out of the box. So every time we call an activity function, when the activity function returns an output, this output is persisted using event sourcing pattern. Then when, let's say, orchestrator function is calling the first activity function, at that time, the orchestrator is dehydrated, and then it's waiting for the response from the activity function. So at that time, the orchestrator is waiting, we are not paying for that execution. So it gets persisted, as the whole state is persisted, and we're not paying for that execution time because it's idle. And then when we receive an event from the activity function, then the orchestrator function rehydrates, and then we start the execution again. Then activity functions are stateless. So this would be our nano services that have a single purpose, and they are meant to execute a single step, they should have a single responsibility. And they would have inputs and outputs, and these inputs would be sent via messages, via storage queues, and then the responses will also be sent via messages. And then the client is the one that starts the orchestrator, and we can also terminate the instance. It can also get the status of the orchestrator. We will see this in the demo. Any questions so far? Yep. How fast is it? Yeah, so dual functions are made for asynchronous processing, right? So you can expose an HTTP endpoint. So because every time you're calling an activity function, you need to put a message into a queue and all that, you should expect some latency. So it's not super fast, but it's fast enough. And then you can, so every time the orchestrator calls an activity function, the orchestrator dehydrates. So it's persisted the state in memory, well, not in memory, in storage, sorry. And then when you receive the response, it has to rehydrate, get that state from the storage, and then continue. So it has some latency. You can also improve the latency. You can say, keep the orchestrator in memory for 30 seconds, for example. If you know that the activity function will reply within 30 seconds, you can say, keep the orchestrator within memory. So don't dehydrate to improve performance. There are some tricks you can do to improve performance, but this is mostly for asynchronous process. If you want something very fast, it's better just to write an API app, HTTP endpoint API app, where you can have all your logic in one single HTTP endpoint. So this is meant for asynchronous process. Yeah, but good question. Any other questions? Cool. So because of the way it works, there are some limitations we need to consider. So the orchestration code has to be deterministic because so when we have the orchestrator executing and calling activity functions, so let's say it calls activity A and then receives the message from activity A, that state is persisted, and then when we receive the response from activity A, the whole orchestrator replays from the top, right? So this also impacts the performance. So every time we receive a response or receive an event, the orchestrator replays from the top, checks if let's say it's receiving a response from activity B, then the orchestration will start from the top and check, do we have a response from activity A? Yes. So it will get that response, and then it will try to call activity B. Do we have a state for activity B? Oh, this is the one that we're getting. So it will persist that state, and then it will call activity C. So every time we receive a response, the orchestrator will start from the top. So definitely has some impact on performance. So this is only fit for purpose when you want some asynchronous programming. Yeah. What about, you said avoid infinite loops? What about just normal loops at the end of the day? I've got the same processing 1,000 entries, let's say, and I want to break them up into 1,000 separate functions. Yep. And process away. So for example, in this case, you can do a fan out. You spin up 100 instances of an activity function, and we will see this later. You can fan out, spin up 1,000 instances, and then fan in. Yeah. So what they mean infinite loops is that you shouldn't be doing so just do until, and your until never is true. because every time you receive a response from that activity inside the loop, you're persisting the state. So imagine every time it rehydrates, the state will be larger and larger and larger. There are some workarounds, but in the code you shouldn't implement this directly. Yeah. So it has to be deterministic, which means we cannot do any random numbers or any new GUIDs or get the datetime. There are workarounds, but we shouldn't do it with the normal code that we are used to do with C# or Java. It has to be non-blocking, so we shouldn't do any I/O on the orchestrator. We should never initiate async operations without using the context, and avoid infinite loops. But for all of these limitations, there are workarounds. So we can use the context, and the context will allow us to generate random numbers. We allow us to have this fanning out and fanning in for these infinite loops. Or we can start the orchestrator, what they call start as new. So let's say we want to have an infinite loop that has some state. Let's say we have a function that is monitoring and has to persist some state. We can persist the state and then start as new, meaning only the last state is persisted. So we don't adding up new records of the state every time. So there are workarounds that we need to follow. Yep. I think I have mentioned most of these. So the messages between orchestrator and activities are via messages in storage queues. Every async call persists the orchestration states into storage, the same in the response. So we persist the function output in the storage. We are using event sourcing pattern behind the scenes. I think I mentioned all of this. The orchestrator is always replied from the top every time it receives a response or an event. And activity functions are not replayed because we have the state coming from the storage. So this is how you would see the code in C#. This is in C#, but you can also write in JavaScript or Java. In Python, it's even, they're working on the Python version of this. You can also use F#. So there are different languages that are supported. So this is, for example, if you want to execute function 1, 2, and 3 in sequence, so you execute function 1, and then you will wait for that, but this await is using the context, right? And then you get an output from that function 1 as an X, and then you can pass that output when you call function 2 as an input, right? So these inputs and outputs have to be serializable because all these values are serialized into a message into storage queue. Right? So it's very simple. So you implement this, and behind the scenes it's all abstracted. So you just say context.callActivity async, and behind the scenes this will put a message into a queue. The activity function will be executed, then the activity function will put the response into a queue, and then the orchestrator will receive the message from the queue, rehydrate, and continue from that point on, right? So there is a lot of magic happening behind the scenes. You just execute these 3 lines of code, and all the magic is happening behind the scenes. Right? And then you can implement this error handling as you would do in C#, for example, with try catch. Right? So you just implement try catch, and then in your catch block you implement your error handling, your compensation fallback. So imagine doing this by yourself, putting these messages into a queue, and then expecting that message coming back from that activity function would be very hard. But this is all abstracted and very simple to implement. Yep, so this is, you call the activity functions, and to signify the engine or the runtime that this is an orchestrator, we just need to put the orchestration trigger attribute in the params of the function. And this is how we are telling the runtime this is going to be an orchestrator. To implement the fan out and fan in, for example, here we are doing a parallel processing with a for loop, right? So what we do is we have a batch process that has some lengths, have different records, and then we do a for, and this is all happening in parallel asynchronously. So we call activity functions with the name of the function, and then we pass the input of the record of the batch, and then we have task.whenAll. So we will continue the orchestrator only when all processes have finished, right? So this is how we would do this these loops and implement fanning out or fanning in very, very easy. Right? So imagine doing this yourself would be very, very hard, but this is all abstracted and very simple to implement. We also have task.whenAny, so we can say, let's say you have, for example, when you're implementing a human workflow, you send an email to a person and you're expecting a response, but you also have a timer. So you say, if after 5 minutes I don't receive a response, then I continue after 24 hours, for example, right? So you can have task.whenAny, and when any of those tasks finish, then you'll continue. You need to wait for all. The client, to tell the engine that the runtime that this is a client, you just add the orchestration client attribute in the param, and then you will have the client, and then with that client you can do, for example, start a new orchestrator. Right? This is the name of the orchestrator. This is the input data that we're passing, and then you can have a response from that orchestrator. You can check the status as well with that client. Okay. Any questions so far? We will see all in the demo. It's very easy to implement. But any other questions that you have? Is it very complex or very, very simple?
Regarding the activity function, my understanding is that the activity function still falls under the Azure function limitation. For example, 5 minutes we need after 10 minutes.
Yes, you're.
Activity can go forward and these sort of stuff. So I assume that limitation is still there with activity.
Yes, you're right. So the question was if the limitations of activity functions are the same as your functions. Yes, even the orchestrator. So the orchestrator, when it's running, you have the same limitations. When it's in memory. When it's dehydrated, then it's already out of those limitations. But yeah, it has to run within 10 minutes, unless you have your dedicated plan where you can, I think, extend it up to an hour or so. Or I think they're working so you don't have any limits. So you have your premium your function, so you have your app service plan, and you don't have those limits. But yeah, if you're running on the consumption plan, you have those limits, and every function when it's executing will have those limits, even the orchestrator when it's in memory. Good question. Any other questions? All good? Okay. So, how many of you have heard of Logic Apps? Quite a few? So, Logic Apps is another serverless offering of Azure, and it also allows you to build workflows. But there are some important differences. So, both allow you to implement workflows on the cloud, on Azure, but the main difference is functions, you implement workflows with code, as you saw in the slides, and we will see in the demo. And with Logic Apps, you do it with a graphic designer. So you have a visual designer. So you have a visual designer, and then you add activities. So if you like to implement a workflow with a visual designer, then Logic Apps is better suited. If you prefer code because your workflow is very complex, or you like to implement all you like the development tools, or you like the testability of the code, then probably functions is better fit for purpose. So in terms of connectivity, functions, they have around 20 bindings. So we can react to events on Cosmos DB, on blobs, on storage queues or serverless queues, but there are only like 20 different bindings, whereas in Logic Apps you have 250 connectors, so you can connect to many different sources and receive inputs or outputs. Functions is portable, so you can run the functions locally, you can run them on containers, you can run them on your server, whereas Logic Apps at the moment can only run on the cloud. So the monitoring and logging capabilities of your functions are limited. So you can use app insights and you can use structured logging, but not as rich as you can have with Logic Apps. With Logic Apps, you would see graphically or visually all the instances. You can resubmit those instances. You have much more management and monitoring capabilities. And both have serverless offering, but also dedicated. So with functions, you can have the consumption plan where you only pay for what you use, but you can also have what they call now the premium plan, where you have at least one instance always waiting for load, or you can also have functions running on your dedicated app service environment if you want fully locked down environments. In Logic Apps, you also, by default, you can run them serverless. You only pay for what you use, but you can also deploy them on what they call integration service environment, and this is fully integrated, fully dedicated and isolated, so it will live within your VNet. So I brought up a blog post where I compared the two in more detail. Okay, so these are additional resources about functions. So they have a Twitter account. You can read the documentation. They have a live webcast. I think they have probably once a month. There are some repos, so it's important that all the code that's behind your functions is open source. So if you find an issue or a bug, or you can increase the functionality, you can contribute yourself. There are some samples as well, and there's also a pro site course, which is quite handy. Any other questions before we move into the demo? All good? I think it's too early for a Saturday, right? Okay. So let's have some fun with the demos. So for this first demo, I have an orchestrator that looks more or less like this. So this is a real implementation I did for a real company. So this company is run by cats. They hire me, the cats hire me to implement this workflow. And they are all about using leading edge technologies. They love serverless. Cats love serverless. So they asked me, can you implement a workflow for us? We want to have a cat interaction workflow where we can, because they have a cat model agency. So when the cats want to apply for this agency, the managers of the agency want to approve if the cat is cute enough or sexy enough or whatever to join the model agency. So they want to have this approval process. So this is more or less the orchestrator that we implement for this real customer. So we built a mobile app. At the moment, I won't show you the mobile app, but the mobile app will drop an image into a blob container. This blob container will trigger the orchestrator, and it will start the process from there. So this orchestrator, the first step is to send an approval via email to the cat manager of the agency. And we'll send a picture of the cat that is applying, and then the manager will say, yeah, approve or reject. And then based on that response, the orchestrator will rehydrate and continue the process from there. There is also a timer because the cats are super busy and they are very impatient. As you know, cats are very, especially the young ones. So they say, if after 5 minutes I don't approve, please reject because I'm too busy and I don't want to approve those cats. And then we implement when any. So either 5 minutes have expired or the cat manager approves or rejects the application. Then we move that picture from the request folder into the approved or rejected folder. Yeah, very simple. So I'm using the SendGrid free edition, so hopefully plays okay with me this morning. So what I'm gonna do, this is a storage account. Thanks for letting me know. So I'm going to show you how easy it is to debug a function. So this function, the code of the function is here in my local machine, and this function is connecting to the cloud, and it's going to be polling that blob container. So I'm going to run this function locally. I have some breakpoints, so I'll show you the code on the go. What I'm going to do here, I'm going to simulate one of these cats is applying via the mobile app. So what I will do, I have this blob container or blob folders, and I'm going to drop a picture here. I'm simulating what the mobile app does. So I will put this picture here, and this hopefully will trigger my function running locally that I'm debugging locally. So I just put it in the request folder, and now it's triggering this function here. Right? So this function is using the functions SDK, and is being triggered by that blob that I just put in the folder on the cloud. Right? So what it does, well, this is the orchestration client. It does some parsing on the name of the file, but at the end it will call the orchestrator. And now I'm going to show you after this. I have this is an orchestrator, right? The orchestrator function. So it's receiving the metadata of the blob. Then I'm going to continue just to show you the important bits here. So what it does, as you can see here, I'm checking if it's replaying. So if if it's replaying, I won't do this. For example, I'm logging some of these entries to App Insights. So I don't log if it's replaying. I don't log those again to App Insights. And now I'm calling an activity function, which is send approval request via email. Right, so I'll continue, let this run. So all of this is running locally. And this is an activity function using the SendGrid binding. So this will send an email. Hopefully the free edition of SendGrid plays well with me. So I should be receiving an email soon. Oh, cool. Yep, so this is 9:46. So it's, yeah, the runtime of the functions was running locally. Now I receive an email, thanks to the sponsors here. And I can approve or reject. What do you think? Shall we approve or reject this cut? Approve? Cool. You like the mustache? I'm going to click approve. So this now is triggering another function, which is HTTP triggered. So what I did when I click the link, it's an HTTP GET that I'm triggering, and then this implements the orchestration client. So now it's calling the client, and this client, what it does, it checks if the orchestrator is still running, and if it's running, then it will send either approve or reject to the corresponding orchestrator. So I will keep running here. And now, in my orchestrator, I'm checking who is the winner. Either the timer, because we implemented the when any, right? So either the approval or the timer would reach first. Then I check who is the winner. If the winner is the email, if the winner is the email, then I do some logic. If the winner was the timer, I would do reject, for example. And then at the end, what we need to do here. So this was my request folder. If I refresh here, this is the function that moves the blob. So now it's gone from requests, right? And then if we check approved folder, it's here, right? So everything happened asynchronously and then everything happened using the storage account on the cloud, right? So the event sourcing and the queues were all on the cloud, and everything I was debugging locally, right? So we can do now another. We can now submit this one to the requests, and now we can reject. So you see the different behavior. So it should trigger this again. So yep, so we have a new instance. I'm going to let it run. So now this is the orchestrator. So it should send another email, sending via email. And just to show you, so this is the activity function that sends the email. Is very simple. So we implement the SendGrid binding. Very few lines of code. We add the to, the content, from subject. So the from is a HTML that I have in my config that I just replace some placeholders. And then this should send an email that I'm receiving here. So hopefully we receive the other request soon. So in the meantime, what I can show you here, I'm going to close this. This is the previous, the one we received previously, right? So if we say reject, this is the previous one. Now it should check the status of the orchestrator, and it's telling me, whoops, the application has expired or been processed, right? So when I click reject on the same email, now it's checking the state of the orchestrator. The orchestrator is finished, so now I can return this message to the user. Hopefully we receive the other application soon. So this one can delete. So again, I'm using the free version of SendGrid, so it doesn't work always. we don't receive it, we can jump into the next demo, which hopefully is a bit more fun. We can drop a new one. We can drop this one. These are requests. I'm dropping a new one. This will trigger, this is the client again. The client should trigger the orchestrator. This is the orchestrator. I'm sending via email. And this is activity function sending the email. So hopefully this time works a bit better. Oh, now we receive the, cool. So we receive this one, right? So we can, this is kitten.jpg. So if I reject this one, then, so eventually, once the orchestrator finishes, the kitten should be moved to the rejected. Yeah, this demo has a lot of moving parts, so. And now if we go to rejected, yep, so this is the kitten, the one we just rejected, right? So everything is happening in my local debugger, right? And everything is connecting to the cloud and all that. So quite a lot of moving parts, but yeah, it worked most of the times because of SendGrid. Yeah, any questions?
No, the question I had was in relation to monitoring or to troubleshoot the one that just didn't get picked. What's the easiest way to have a sort of dashboard where you can, with the external endpoints that you integrate with, like SendGrid, can you, what's the easiest way to observe the behavior?
Yeah, this is a very good question. So before I was paying for the SendGrid, it was not failing, but the free version does fail. So in this one, it's a very tricky one because it fails when it sends the email. So the activity function believes that it succeeded its task because you see you didn't see any error here. So this is very tricky, and this is a problem with the external API. So this is the SendGrid API return 200. HTTP, can you hear me? Okay. Yep. So return 200, but from that point on, we don't have a way to know, right? So this is very tricky one. When I was paying for this SendGrid, it was behaving okay. But coming back to your original question, so you can implement logging with App Insights. Also, when you are executing, every activity function will log some metadata to App Insights, so you can have custom queries to monitor that. And you can also, for example, see all the execution history of your orchestrator. You can see the status and all that. But you can also see on real time. In the next demo, I'm going to show you how you can check the status for an orchestrator in real time. Yeah. But this particular case is very tricky because you are relying on a third-party API, and the third-party API tells you, yeah, everything is fine, but at the end, that API didn't do what it was meant to do. Sometimes it takes, I don't know, 10 minutes, and then we receive the email when the demo is over. So let's see if, no, we haven't received it. But yeah, I've seen this in the past. So this is to do with the API. Cool. Any other questions before we move into the next demo? Yeah, so the orchestration client is the one that can instantiate a new orchestrator function and can also check the status. So for example, when we receive the approval or the rejection from the email, it's a client, and this client was the one checking the status. Is this orchestration running? If it's running, then it will send the message to the orchestrator. If it's not running, then it will return, oops, this workflow has already finished, for example. So with the client, you can start an orchestrator, you can check the status, you can terminate. Right? So with this client, you can also say, this instance of an orchestrator, terminate, we don't need it anymore. Yeah. And the orchestrator is the one that has all the workflow, calling the functions, the activity functions, implementing retries, finding out and finding in. The client is very simple. The orchestrator is the one doing all the hard work of the workflow.
But we can deconstruct like the orchestration for yourself. You can trigger without
No, it works like that. So let's say you have in this case, what's a block put into a container, right? So that block has to trigger a function that is triggered with the, let's say, block trigger. And this block trigger function will have an orchestration client parameter. But the trigger is a block. Can be a message on service bus, can be a message, right? So, and then the orchestration function is triggered with an orchestration trigger. You always rely on a client that is calling the orchestrator. Yeah, good question. Any other questions before we move into the next one? Cool. So next demo. So for example, this one, now it should be the one that is expiring from the one that, you see, the one that we didn't receive the email, now it's expiring because we have the one any. So now we are not getting a response. It was the timer that expired. So now if I continue this, the waiting time has exceeded. And then, so this will eventually move that block into the rejected because it was a timer, right? So at least this failure on SendGrid allowed me to show you also the timer that continued the orchestrator. So, yep, eventually this will move. Yep, so now we have the other one. The one that we didn't receive the email, now it's in the rejected because the timer expired. Yep. Cool. So now next demo. Oops. Oops. So next demo is based on the same scenario, but in this case, instead of using SendGrid, I'm going to use Slack. And the fun part is that you can, so it's going to be very similar, but instead of using email, I'm going to use Slack. So I'm going to use the Slack APIs. And the fun part is that you can let your cat apply. Just make sure that you submit only content for all audiences because there are kids in the audience. But feel free to submit your cat, the best picture of your cat, send it to this email, and make sure that you put this subject. The subject is not case sensitive, but make sure you put this subject, I want to be a foreign model, and make sure that you apply your cat best picture and see if we can see if the cats that are managing the model agency like your cat or not. So this is running on the cloud. This is not running locally, right? So this function that I showed you, it's deployed on the cloud, and this should trigger eventually the process. And instead of receiving it via email, we're going to receive it via Slack. So hopefully you have some cats that are not too shy to apply. Do you need more time for these details, or are you all good? So functions don't have, so they have the SendGrid binding to send emails, but they don't have a binding to receive emails. So in this case, I'm relying on logic apps, and logic apps are the one polling my email, this address, checking if there are emails with this subject, and then if there are emails with this subject, we'll grab the attachment and we'll put that attachment into the block. Right? So I'm relying on a logic app that is doing that part, and then from that block on, everything is executed using the same function, but this function is deployed on the cloud. So I'm going to show you quickly. So this is the logic app. For example, this is a previous execution of a logic app. So receives this logic app is polling this email, and then checks if the subject checks the subject. So now we're receiving. We have received some applications here, right? So checks the subject and then checks for, so this is the logic app. This is a visual workflow, and then gets the attachment, and it will drop the attachment into the blob. Cool. So now we have some applications here. So these applications are coming from the audience. So very cute cat here. So what do you think? This cat deserves to be approved? So what we can do, and I'm going to show you how to check the status of a workflow, right? So hopefully they don't mind using their email, but I'm going to check, for example. So I have an endpoint. This endpoint is using the orchestration client, right? So the cat has an email, and then the cat is telling, can I get the status of my application? So this HTTP endpoint is another activity function. It's another client orchestration function. So I pass this email, and it's telling me the status of this application. So the custom status is what we can set up, and we are currently reviewing your application. Bear with us, right? So we can check the status of an instance of an orchestration. So let's say, nice one. So let's say we approve this one. Yep. So we approve this one, and then now if we check the status for this application again, approved. Congrats. You're super special, right? So we can have this custom status per instance, right? And then the client the orchestration client can check the status of the workflow, right? And I mean, the solution it has a lot of moving parts. Again, I don't know what's happening with the projector. So the solution has a lot of moving parts, but the code itself, and this solution, because I'm connecting to Blob Container and to SendGrid and all that, and to Slack, but the code itself is, the code to implement the orchestration is quite simple. So you don't worry about all these messages happening in the background. It's all abstracted for you. So what do you think? Reject? And for example, when we're clicking this approve or reject, so I'm going to show you just in case you're curious. So I have my config. So in my config, I have, for Slack, if you send some JSON format when you hit the Slack API, this JSON will render as interactive messages, and these messages will allow you to have these buttons. So I'm sending this message to Slack saying, please approve or reject. It's just a JSON that we send to Slack. So Slack will send this rendered with these buttons, very easy. And then once you click accept or reject, I'm going to show you here. So this, again, this is an orchestration client here, and this is HTTP triggered, right? So this is the one receiving the response from Slack. And we have a callback ID, right? So in the callback ID, this is where we send the orchestration instance, right? So when we receive the message back from Slack, we can correlate, okay, this approval or rejection is related to the instance of an orchestration, right? So we receive that back from Slack, and then we can correlate. And this is the one checking the status of the orchestrator, and then we prepare a message that we send back to Slack, right? So what we are seeing here in Slack, thanks for your selection, right? Is based on what we are sending from this HTTP trigger function, right? So we return a HTTP 200 with this content, and then Slack renders that when we approve. What do you think? Approve or reject? Approve. Nice wildcat. Cool. So this is scared because we should approve, otherwise this cat might kill himself. Best model, yeah, approve as well. Awesome. So this again, so this Slack is, so to create this application in Slack, you just create an app. So you have your organization, then you create an app, and then this app would give you endpoints. And then what we are doing from here is we give an endpoint. Yep. And then I'm not showing this because it has all my secrets, but the actual one. But here we will put the endpoint, and then with that endpoint, this is how we are interacting with Slack. Very simple. And then again, when we click approve or reject, again we are calling another HTTP triggered function which returns this message. And again, this is the client that is calling the orchestrator, and then the orchestrator will continue. Okay? Cool. Awesome. Thanks so much for your submissions. Hopefully your cats are happy. So the demos, the code of the demos are in GitHub. So if you go to my GitHub repo, you would see all the code. It's very, very simple. So this is updated to the latest SDKs. I was doing that last night, but it's running on the latest SDKs. And then I have 2 blog posts where I describe how I build these 2 demos. So I describe how I connect to Slack, how I connect to SendGrid, and all that. So in case you want to play around with your functions, or you want to implement a cat workflow, you have all the code there and all the instructions to do it yourself. Keep your cat happy. Any other questions or comments? Did you like it? Yeah.
So explaining your integrations, what's the offline support? Like if you want to work locally with shareable functions, what's that support like at the minute?
Yeah, so the runtime can run anywhere. So it can run on your local machine, on containers, so the runtime, just the runtime. And then they also have like a management portal where you can deploy, and you can, for HTTP triggered functions, you can see, you can enable, disable, very similar to the cloud experience, but yeah, still maturing. But the runtime is fully functional, so you can run functions anywhere. Mm-hmm. And so for example, every time you need a binding, you just download that extension. So the overall function will be another extension. You need to download that NuGet package as part of your solution. And as long as you have the runtime with those extensions, you can run. So for example, the SendGrid binding or extension, and then the old extension, HTTP extensions, all those you download as part of your solution. You deploy where your runtime is installed, and that's it. Mm-hmm. Yeah.
I was wondering how the timer works with hydration, dehydration.
Mm-hmm. So the timer, again, has to be a client. So let's say, for example, you have a monitoring function, right? So let's say you have a monitoring function that stores the state, and let's say you're monitoring some IoT devices, for example, and you want to check the status of those devices every 10 minutes. So the timer would be a client, but you have the timer trigger, and that timer trigger function would have an orchestration client, and this orchestration client would be the one that would connect to the IoT devices, store the state, and then, for example, start as new, something like that. Yeah. So you still need to have that orchestration client with the different trigger. Mm-hmm.
Can I connect the Azure function with Microsoft Teams and other platform?
Say that again?
Connect to Azure function with Microsoft Teams.
Yeah, so with Teams you can also have, I haven't done it, but I know that you can create apps, and then you can connect to the apps via HTTP, same as Slack. So for Slack there is no bindings, it was just HTTP endpoints. Yep, so I think Teams support the same. I haven't done it, but I think with Teams you can create apps, and then you can expose those endpoints and send those messages, no issues. Mm-hmm. Any other questions? All good? Okay, thanks so much for your time. Hope you enjoyed the talk. See you next time.